Hello everyone. Today we are going to work on 5.3, which is more integration and some applications. We have been looking at integration using substitution, so we're going to do a little bit more of that. Then we're going to look at some applications and see some integration in the scheme of business, and then also some biology applications. Okay, let's run through a couple examples just to kind of get us back in the groove. Let's say that I asked you to find the integral of x squared over 3 minus x cubed dx. Now remember that when we see a fraction in an integral, we almost always want to try to simplify that. But a lot of times that's not going to be easy, and in this case this is definitely not going to be easy. So what we're going to do here is we're going to look at a substitution. Now remember that you're supposed to look at the ugliest part as being your substitution. So to me that definitely looks like the denominator. And we're going to take the whole entire denominator. Let's let u equal 3 minus x cubed. And then remember, as soon as we find u, we need to follow it with du. So du will equal negative 3x squared dx. Right? Now remember, we're supposed to look up at the equation, or the problem, and see what we have there. And when we look at the problem, I see that we've got the x squared dx. Everybody see that? But we don't want the minus 3. So we're going to divide out that minus 3. Minus 3, minus 3. So we end up with du over negative 3 equals x squared dx. Now we are ready to do our substitution. So we have the integral, and now all that's going to be up top is 1 over, and the bottom is going to be just u. Now, in place of the x squared dx, we're going to put the du over negative 3. But remember, as we talked about in the last section, that negative 3 is just a constant that's going to come along for the ride, so we can move it all the way out to the front. Negative 1/3 integral of 1 over u du. And in the end, the problem actually seems a lot easier. Now, we have to remember, this is the one that I told you about. If you remember it, it's easy. If you don't, you can work a long time and not get anywhere. Who has a derivative of 1 over u? And remember, the answer is the natural log. So the antiderivative of 1 over u is ln of u. ln of u, and then don't forget your plus c. Remember, last step then is to resubstitute this u back in. Negative 1/3 ln absolute value of 3 minus x cubed plus c. So remember that 1 over u guy, that's the one that's easy if you remember, but a real pain in the butt if you don't remember. Okay, let's look at a different one then. Let's see what else we've got here. How about this guy? The integral of e to the 5x, lost my spot, minus 3e to the 3x plus e to the x all over e to the 3x dx. So this one, we've got exponential function going on in there. It's definitely ugly. We've got lots of exponents. And so your first idea, now that we're into the groove of substitution, might be to substitute. The only thing is, to me, this looks like the uglier part of the problem. And if we substitute and we take the derivative, right, because we have to take the derivative, it's still going to be super duper ugly. It's not going to get much simpler. So this is one of those examples where what we're going to do is think about rewriting the fraction. Now notice that this is an e to the 3x just on the bottom. We could split this into 3 fractions. So e to the 5x over e to the 3x minus 3e to the 3x over e to the 3x plus e to the x over e to the 3x dx. Now certainly it looks uglier here, but we can do some canceling, and that's going to get rid of our fractions for us. So either think about canceling or think about subtraction. For this first one, if we think about subtracting the exponents, we'll have 5x minus 3x, which will be 2x, minus 3. Now both of these guys are going to go away. Boop, boop. Then over here, again, we want to think about this as subtraction. So if this is 1x minus 3x, this is going to be negative 2x dx. Now, remember that when we're taking the derivative of the e to the 2x, or the e to the x itself is its own derivative or its own antiderivative. Now, if we were taking the derivative of e to the 2x, we would then multiply by the 2, wouldn't we? Now, we're not taking the derivative, we're taking the antiderivative. So when we take the antiderivative here, we're going to write down e to the 2x, but instead of multiplying by 2, we're doing the anti, we're going to divide by 2. So the antiderivative is e to the 2x over 2. Now, the antiderivative, again, here is going to be minus 3x. And then one more time here, this we're going to write down e to the negative 2x, but we're going to divide by negative 2. And then put plus c. So there are times when you don't need to use substitution. In this case, this would be one where substitution is probably going to make your life a bit uglier. And the way we've got it, we don't have to do that. Okay. Let's see if I've got one more here for us to practice, and then we'll do some word problems. How about this one? The integral of 9x e to the negative 2x squared dx. So another one with the exponential function in it, another one that's a little bit on the ugly side. Definitely with this 9x out front, not something we want to just try to do without using a substitution. Now the question for our substitution is, what are we going to let our u equal? And when we look at this, the exponent, even though this is multiplication and to me this looks uglier, the exponent is actually the ugliest piece of this. So we're going to let our u equal the negative 2x squared. Then immediately we're going to say du equals negative 4x dx. Now this is the first time that this has happened to us. When we look up here, we definitely have the x dx, don't we? But we don't have the negative 4. The numbers don't match up, do they? So we are going to take this negative 4 and we're going to subtract it, or I mean not subtract it, divide it to the other side. So we have du over negative 4 equals x dx, so that we can do our substitution. But now when we do the substitution, we'll have the integral, and the 9 isn't going anywhere. So we still have a 9 out here. The x and the dx are going to disappear. We now have e to the u, and in place of the x dx, we put our du over negative 4. Now, just like before, we can pull that -4 out to the front. It's just a constant. It's not going to affect us. But what we also will want to pull out is the 9. Get everything out of there that's not helpful to us. So we'll say 9 over -4 integral of e to the u du. So by removing everything that's at all ugly or doesn't fit with the problem, we're then left with something very simple. So when we go to take the integral, 9 over -4, the antiderivative of e to the u is just e to the u plus c. One last step, remember to put your u back in here. So we end up, I'll just write it down here, -9/4, or 9 over -4, doesn't matter where the negative is, e to the -2x squared plus c. Look good? Now let's look at some word problems here. So let's look at this one. This says the rate of change in revenue for Priceline.com from 2004 to 2013 is dr dt equals 0.07 e to the 0.2387 t, where R is in billions and T in years, with T equal 4 corresponding to 2004. In 2013, revenue was 6.8 billion. Find the revenue function. So, when we look at this problem, it's important that we realize what they've given us. And they state it here that they've given us rate of change, and then they also state it here in that they've given us the derivative notation. In this problem, we have been given the rate of change. We have been given the derivative, and what they want us to do is to find the revenue, which means we're going to go with the antiderivative, right? Antiderivative. Now notice that they're in t here, so we're just going to do this with t rather than x, but no problem there. So let's go ahead and write what the integral should look like. So we'll have the integral of 0.07 e to the 0.2387 t dt. Now, again, we've got that e to a power here. Now, again, if we were taking the derivative, we would multiply by the 0.2387. We are taking the antiderivative, so we are going to divide by the 0.2387. And this 0.07, he's just coming along for the ride, isn't he? So 0.07 e to the 0.2387t divided by 0.2387. And then don't forget your plus c. So we have found the antiderivative, which means that this guy right here is the revenue function. Now, when you think about revenue functions, think about the functions that we've already seen in this class. Do they have a plus c hanging on the end? They don't, do they? Okay, no function that we've ever seen has just this random plus c. There's always like extra numbers or something like that, a constant on the end. So this is where we want to use some more information to help us figure out what c would equal. And that comes into play in this last bit right here. So they told us a bunch of information. They told us that we were in billions of dollars, in years. They told us that t equals 4 equals 2004. But then they said this, the revenue was 6.8 billion in 2013. Now, what that means is if we plug in 2013, or just the number 13, right? Not 2013, but 13 here, and a revenue of 6.8 here, we should be able to calculate this out and figure out what our C is. So we can come up with the actual revenue function. So let's go ahead and do that. So we're going to put 6.8 equals 0.07 e to the 0.2387 times 13 all over 0.2387 plus c. Now is the time for the calculator. So I'm just going to calculate this whole thing and see what it equals. It's going to be some ugly fraction, but we need to figure it out. 0.07 e to the 0.2387 times 13 divided 2387. Boop. Okay, let me make sure I put it in correctly. That's good. So I have 6.8 equals 6.53 plus c. Okay, so that's what I got, that it came to about 6.53. Okay, now in order to get that c alone, we'll just subtract. So minus 6.53, which will give us, let's see, put a 0 on there. So that'll give us 0.27 equals C. Okay, make sure that I didn't screw this up. Look good? So we get that the revenue function is R equals 0.07 e to the 0.2387t over 0.2387, and now at the end we can put plus 0.27, and we actually have the full revenue function, not the one with the C. So that's the key when you're doing the word problems here, is that when you're doing the antiderivative and you put that plus C, if it's a word problem, they don't want the C in it, they want the real world answer, so you have to figure out what C would equal. So let me find one more, let's do one more here, and so this is a gardening example, and it says, a nursery sells a type of shrub after 5 years of growth. The growth rate during those 5 years is dH dt equals 17.6t over 17.6t squared plus 1 under the root. So where t is in years, and h is height in inches, and seedlings are 6 inches when planted. Find the height function. Okay, so again in the problem as you read it, it's telling us that we have a growth rate. It's also giving us the dH dt notation. So with the growth rate and the dH dt notation, we know that we have a derivative here, and we want to go backwards. We want the original height function, so we want to go for the antiderivative. So we will set up our integral 17.6t over the square root of 17.6t squared plus 1. And again, we're with dt. Okay, so dt. So we're looking at time. All right. Now, as you look at that, I hope you agree with me that it's not the prettiest thing. So we've got a fraction going on here and a root in the denominator. Totally not pretty. So I think that the ugliest part is definitely the denominator, but I don't really want the square root in my substitution. That's going to make the substitution ugly. I'm just going to go with what's underneath it. So we'll let u equal 17.6t squared plus 1. Now, I'm also thinking ahead because I've done this a number of times, not this problem, but I've done antiderivatives and substitution a number of times, that when I take the derivative here, things are looking good up top. But I have to bring this 2 down, aren't I? Now, the thing is when I bring this 2 down, I'm not going to multiply it. I'm going to leave it as 2 times 17.6t, and then dt. So instead of multiplying through when I find my derivative here, I'm going to leave it. And the reason we're leaving it is because in the problem up there, do you see the 17.6t dt? So the fact that we have matchy-matchy here really works for us. If I multiplied through, then the number isn't quite so clear anymore. So I don't multiply through, and then I can see that substitution. So what I need to do is just divide out the 2 to the other side. So we'll have du over 2 equals 17.6t dt. Now the substitution will look much better. So we'll say the integral, I know up top we're just going to have 1 over the square root of u. And then in place of that, I'm putting du over 2. Now we still have the fraction and we still have the square root, but remember, we can do some simplifying. I'm just going to pull this square root to the top and I'm going to change it into its exponent notation. Can I also bring this 2 out to the front? So we'll have 1/2 the integral of u to the negative 1/2 du. Excuse me. Look good? Okay, now I know we haven't used this rule, the basic power rule here in a while, but let's go ahead and do it. So the 1/2 comes along for the ride. We're gonna have u, we're gonna up the exponent. So we're gonna up it by 1, which will take it to a positive 1/2, and then we're gonna divide by that guy, by the 1/2, yes? And then we'll put plus c. Now the one nice thing about this one is that 1/2 is really helping us out because the 1/2 and the 1/2 are going to cancel. We need to put our u back in there, but we end up with a u, or a function of 17.6 t squared plus 1 under the square root, right? Because we could turn that back into the square root, and then plus c on the end. But remember that this was a word problem, and that doesn't tell us the exact height function because of the c. So we come back over here and we say, it said when seedlings are 6 inches when they are planted. So 6 inches when they're planted would be a time of 0, right? When they start off the process, time would be 0. So if we stick in a 0 in here and we set it equal to 6 inches, we should be able to figure out what t is. So we'll say 6 inches equals the square root of 17.6, and then I'm putting in 0 plus 1 plus c. Now I'm running myself out of room, so I'm going to come right back up here and get rid of this. Oops, black pen doesn't erase. So that's going to leave us, that goes away and just leaves us with the square root of 1. So we have 6 equals 1 plus c, so c equals 5. So in the end, the height function will be h equals the square root of 17.6 t squared plus 1, and then on the outside, plus 5. That's our c. So we found our height function. Now, the problem does go on a little bit more. The problem then says, how tall are the shrubs when they're sold? Yes, I don't need 2 periods there. Now remember that this was a 5-year process. They're going to sell the shrub after 5 years of growth, which means if we want to know how tall they are when they're sold, we want to know what the height is when t equals 5 years. So can we stick in 5 into our equation? H equals the square root of 17.6 times 5 squared plus 1, and then a plus 5 on the outside. Once again, back to the calculator. Square root of 17.6 times 5 squared